All right, this is Unit 5, Lesson 3. We are still working with polynomial functions, and this time we are talking about roots and zeros of polynomial functions, as well as something called multiplicity. Hopefully we remember that when we say zeros and roots, that means where we cross the x-axis. So our vocab here, the points at which the function intersects the x-axis, those are our zeros. That's how we refer to them. And there's, again, a few different names: roots, x-intercept solutions, zeros. All mean the same thing, where we cross the x-axis. It says a polynomial function in the degree n can have at most n real zeros. That means if we have x to the 4th power, the degree would be 4, so at most we could have 4 real zeros. If our degree is 2, or have x squared as our highest point, at most we could have 2 real zeros. Okay, so it just kind of matches up that way. It says an even degree polynomial has an even number of zeros or no zeros at all, because we could be above or below the x-axis and then head in a direction so that we never cross the x-axis. An odd degree polynomial has an odd number of zeros. And because odd degrees have to go in opposite directions, if you remember, we have to cross the x-axis. So we will have some real solutions always with our odd degree functions. Okay, for this first problem, we are being asked to graph the function and then identify the zeros. Again, if you're working on this from home, I recommend using the Desmos app. That's even what I'm using here from home. To type it in the equation, again, you'll type in you'll type in the x cubed plus x squared minus 2x into the equation part, and it puts the graph on there right away, and then it lets you label everything on here. So let's go ahead. I'm going to say it and put them on and graph it while I'm talking to you. So let's work from left to right. I have a point at negative 2, 0, which will be right here. And then I'm going up to negative 1.2 and 2.1. Negative 1.2 and 2.1. It's about right here. And then I go back down to 0, 0. I go down about halfway, half and half, just about right here. And then I go to 1, 0. Okay, so this is all the dots basically that my Desmos app is showing me, and I'll connect my points. I'm looking at my picture. I'm just kind of making sure it all matches up as best as I can. Turn and go down, down, turn and go up, and up forever. Okay, pretty good. Now, graphed it, and now it just wants me to identify the zeros. The zeros, if you recall, are just where we cross the x-axis. We did it with quadratics, and now we're doing it with higher degreed functions. So we only want the x values, or the roots. So we would say x is equal to, the x value of the first one was negative 2. Okay, this is negative 2 right here. 0, and then 1. So I'm just making a list of all the x values of where I cross the x-axis. So where I circled it, and that's it. It's so easy, and it's so great. Love it. We like roots and zeros for our polynomial functions. Okay, we're going to do this again with number 2. Now I have a quartic function. I have negative x to the 4th plus 4x cubed minus 2x squared minus 4x plus 3. So I type that equation into Desmos, and I can see that both arrows in down, but I have a point at negative 1, 0, and then we go up about halfway in at 4 right here, and then I'm going down to 1, 0, which is a dot right there, 2.4 and 4, about 2.5 and 4. I come back up, and then I'm at 1, 2, 3, 0. And I'm going to connect my points. And if you're looking at your picture, you should see the same thing. Go up, we go down, we go up, we go down. Okay, it's kind of like an M. Looks pretty cool. Okay, now again, what are we answering here? We're identifying the zeros. So anywhere we cross this x-axis. So 1, 2, 3, cross or touch, I should say. Now this first 0 was at negative 1. This one is at +1. The next one was at 3. So we would say x equals, our zeros are at -1, 1, 3. Those are all the places where we cross the x-axis. So we don't always need to graph a polynomial function in order to see its roots or zeros. Another way to find out where a function crosses the x-axis is by factoring, and we did a lot of that with quadratics. We can factor polynomials lots of different ways, but let's start off, and it'll be very similar to what we've been doing with just a little bit of a change for our factoring here. So it says write f of x equals x cubed minus 2x squared minus 15x in factored form. And then we'll pull the zeros from the factored form by t-barring it. Yeah, you heard me, t-bar. We're going to do it. Now I start by looking at my function, and I always look for a greatest common factor first. So if I'm looking at x cubed minus 2x squared minus 15x, notice I said x for all of them. So I have a GCF of an x. I'm going to pull that out of each function. So that gives me x parentheses, and now I'm taking one x out of each. So x squared minus 2x minus 15. Now remember, we only do like 1, 2, 3 factor tree if it's an x squared, a quadratic. And by taking this x out from the front, I now have a quadratic, okay, in here. So I can do 1, 2, 3 factor tree. See, it's all coming back to what we're used to. What multiplies to -15 and subtracts to -2. Okay, those two numbers will be -5 and +3. So again, we're supposed to write this in factored form. So we would say x parentheses x minus 5 parentheses x plus 3. Now this right here is factored form. But the next part of the question is down here at the bottom. It says, what are the zeros? We get zeros from t-barring this. So I'm going to t-bar this. And remember, each section is set equal to 0 and solved for x. So they kind of come out to the opposite. But what if it's just an x here? Remember, that still gets set equal to 0. There's nothing left to do. So one of our zeros is 0. If I have x minus 5 equals 0, it comes out as +5, the opposite sign. If I have x plus 3, it comes out as x equals -3. So my zeros are x equals 0, 5, and -3. So I factored, I t-barred, and I got my answers. That's a very familiar concept. We just tested on this not too long ago, and I feel like you guys are rock stars at it. Okay, now we're going to talk about multiplicity. Okay, multiplicity. Oh, hold on, my marker's not working. Multiplicity right here. It says the multiplicity of a 0 is equal to the number of times the corresponding linear factor occurs. And really, it's like whatever the exponent is attached to like our x or our grouping, the factor. And that tells us the multiplicity. And then we'll learn what the multiplicity tells us about the graph. So let's just start and see what that all means. I've got f of x equals x cubed minus 6x squared plus 9x. I'm supposed to factor this first. Again, I can see that these each have an x, so I need to pull one x out. I always pull out a greatest common factor if there is one. That's always your first step of factoring. So we have x parentheses x squared minus 6x plus 9. Now by taking that x out, I left me with a quadratic inside the parentheses, so I can do 1, 2, 3 factor tree. What multiplies to 9 and subtracts to -6? That will be a -3 and a -3 because they multiply to 9, subtract to -6. So I can write this as x parentheses x minus 3, or we could think of it as x times x minus 3 in parentheses squared, because that squared means I had 2x minus 3 factors. Okay, so we like this form. Okay, now we can get the zeros. It's asking us what's the zeros and their multiplicity. So if I t-bar this, I have a 0 at 0. I have another 0 at 3. So let's write that down. One 0 is at 0. And put a comma. The other 0 is at 3. What is their multiplicity though? Multiplicity comes from the exponent that was attached to that factor. So for this x, it was a power or degree of 1. So we would say it has a multiplicity of 1. pretty easy. And then we'll interpret it in our next section of the notes. When I had my 0 of 3, well, that came from the factor of x minus 3, and the exponent attached to that was squared. So we say at x equals 3, we had a multiplicity of 2. And that's the part we're answering for now. Again, we're going to talk about what that means here on this next slide. So let's go to it right here. So now we're supposed to graph this function that we just factored and found the zeros of. So it's the same equation as what we just had before. It's x cubed minus 6x squared plus 9. Okay, so let's graph it. Typed it in, and I got a point at 0, 0, 1, and 4. So 1, 2, 3, 4, and 1, 2, 3, 0. I'll connect my dots. So we go up, turn and go down, turn and go up. So here's my graph. So notice the zeros, we had a 0, we said at x equals 0, and the multiplicity was 1. We had a 0 at 3, and we said its multiplicity was 2. So let's look what was happening at those zeros. Here's my 0 that was at 0, and that multiplicity of 1. So let's look at this code. The multiplicity is odd, 1 is odd. Then notice at the 0 that we crossed right on through. So we say that the graph crosses at that 0, and that kind of got chopped off. Crosses at that 0. That's on your notes. Okay, so again, we had a 0 at 0, an odd multiplicity, and we did continue up through that 0. But our next 0 at 3 is right here. Now, it had an even multiplicity. Its multiplicity was 2. So as we were going down to down to that 0 at 3, we turned around and went back up. We didn't pass through it. We could call that a touch or a bounce. This set of notes calls it a bounce. It could be a tangent. There's lots of different ways to describe it in math. But the rule is, if we have a multiplicity that is even, like 2 is even, we don't cross through the 0 to the other side. We turn or bounce at that 0. Or turn. Okay, at that 0. So that's the big rule. Odds cross, evens bounce. It's very simple, but try to get it ingrained in your brain, and we're going to use that to help us with questions 6 through 8. Okay, on numbers 6 and 7, we are asked to identify the zeros. Okay, let me underline that. Identify the zeros, state the multiplicities, and the effect on the graph. The effect is, we're going to say cross or bounce. All right. Now, to find the zeros, it has to be factored, and then it has to be t-barred, and we get our numbers out of there. The cool thing about number 6 is that it's already in parentheses. If it's already grouped into parentheses, it's already been factored. So we can already t-bar this one. So I'm going to draw my t-bar, and I'm going to pull out. If I have an x plus 7, even though there's a square there, this is for the multiplicity. Okay, those exponents. Exponents are the multiplicity for each of these zeros. So x plus 7, if I say x plus 7 equals 0, we have to minus 7 from each side. So my 0 is at negative 7. Its multiplicity is the exponent. So its multiplicity is 2. Because 2 is even, we're not crossing through at that 0. We're going to bounce. So that's what we write down. Very easy. My next factor is 2x plus 1. So again, we say 2x plus 1 equals 0. To solve this, we would minus 1 from both sides, so 2x equals negative 1, and then divide by 2. So I have a 0 at negative 1/2. The multiplicity comes from the exponent around these parentheses. There is no exponent, so we would say the multiplicity is 1. 1 is an odd number, so we're going to say we cross through this 0 that is at negative 1/2. And last, we have a factor of x minus 4. So what's coming out of that t-bar will be x is equal to positive 4 when solved. And so 4 is the 0. The multiplicity again is the exponent. It's 3. Now, is 3 even or odd? It is, it's odd, sorry. I was having a coughing fit a second ago. So because it's odd, it crosses. So odds cross, evens bounce. And that's it. We are done. We could kind of make a rough sketch just from knowing like the zeros and their multiplicity. The only thing we're missing here is kind of our mins and our maxes. Okay, now number 7 is a little bit different because if you notice, I don't have any parentheses. This one has not been factored yet, so I can't t-bar it until it's been factored. So I'm going to start by looking if I have x to the 4th minus 2x cubed minus 8x squared, I have a greatest common factor of x squared. So I'm taking x squared out of everything. So I'll have x squared and then parentheses, because remember GCFs always go on the outside. I have x squared minus 2x minus 8. Now I'm not done factoring. What I'm left with now is a quadratic inside here. It's a 1, 2, 3 factor tree. What multiplies to negative 8 and subtracts to negative 2 will be negative 4 and positive 2. So writing this in factored form, okay, I'm going to move this up a little bit. We get, oh my goodness, I'm making it all crooked. Ugh. Okay, is x squared parentheses x minus 4 parentheses x plus 2. Now that it's been factored, I can t-bar between each of my factors and get my solutions. So if I have x squared equals 0, I would square root both sides, and the square root of 0 is 0. So one of my zeros is at 0. What's its multiplicity? I look back at the factor, and it was squared. So that squared is my multiplicity, 2. Because 2 is even, we are bouncing at that 0, not crossing through. Okay, if I have x minus 4 in parentheses, it comes out as positive 4. That's the 0. There is not an exponent, so we would say the exponent is 1. 1 is odd. Odd multiplicities cross through to the other side. My next 0, if I have x plus 2 equals 0, it comes out as negative 2. It also does not have an exponent, so it's thought of as 1. And because 1 is odd, it crosses through. Okay, on number 8, we're going to work backwards a little bit. It's going to give us the zeros and the multiplicity, and then we have to write the equation. And I know that you have a question like this on your homework. So it says a polynomial function has a 0 at negative 6. So if it comes out of the t-bar as a negative 6, inside the parentheses, it had to have been the opposite sign, a positive 6. So I'm saying there was a factor of x plus 6. That's what it looked like back before we t-barred it. And it says it has a multiplicity of 2. Remember, the multiplicity is the exponent, so we're going to put an x squared right there. And then we have another 0 at 2, positive 2. So if we have a 0 at positive 2 inside the parentheses, it had to have been a negative 2, and its multiplicity was 1, or technically no exponent there. Now it wants to know the polynomial function in standard form. That means we have to multiply it all out and write it from our highest exponent down to our lowest exponent. So the first thing we need to do, remember we can only multiply 2 binomials at a time. So I'm going to start with this x plus 6 squared. X plus 6 squared means x plus 6 times x plus 6. So we're going to FOIL. So x times x is x squared. Then we have a plus 6x. And then we come into our insides and we have another plus 6x. And 6 times 6 is 36. Our middle two are like terms. So this is x squared plus 12x plus 36. I'm going to wrap that back up in parentheses, and now I'm going to multiply it to the x minus 2 factor. And I like putting that one in front. You don't have to. I just like having my lesser amount of terms as my front factor. And now we're going to distribute, multiply. So x times x squared is x cubed. X times 12x is 12x squared. X times 36 is a positive 36x. Okay, we got to the end, so now we come back to our first set of parentheses, and we're going to take negative 2 for its turn to multiply. We're going to get negative 2x squared. Negative 2 times 12x is negative 24x. And negative 2 times 36 is negative 72. To finish it up, we'll combine like terms, starting with my highest exponent down to my lowest. So we have an x cubed 12x squared minus 2x squared is 10x squared. Then my x's, 32x minus 24x is 12x, so plus 12x. And then I'm left with my constant, negative 72. So I'm just going to say f of x equals this, and I have my function. This function of f of x equals x cubed plus 10x squared plus 12x minus 72 had a 0 at negative 6 and a 0 at positive 2. Okay, to finish up these notes, we're going to make this paper. This would be a gold paper. So if you are doing notes from home, I would make sure I get this one down because you get to use your gold papers on tests. So this is characteristics of a polynomial function, and we're going to start off by graphing x cubed minus 6x squared plus 8x. So I type that into Desmos and I get a point at negative 4, 0. So 1, 2, 3, 4, 0 is right here. And then I have a point at negative 3.15 for x. So we're going 3 left and a little bit more. And at 3.079, so up 1, 2, 3, and just it's about right here. And then we have another point at negative 2, 0. We are at negative 0.8, so almost to negative 1 for x, and we're down a little past negative 3 right there, and then we're at 0, 0. Okay, so here's all my dots. It looks a little bit messy, but then I look at my picture, what I graphed, and I'm going to connect all my points. So we're going up, down, up. All right. So we're going to go ahead and we're going to answer a lot of these questions. Okay, I'm going to start over here on the right. My parent function. Okay, where does this come from? Where does it originate from? And that's kind of from the degree of the function. It is, the highest degree is cubed, so this is a cubic function. So that parent function is f of x equals x cubed. Okay, and it does have that basic shape. It's been shifted because we've added more terms, but it does come from an x cubed function. Okay, and behavior. So we're going to say our right side is positive infinity, our left side is negative infinity. Okay, we're going to answer this. We're going to say as x approaches infinity, well, let's put a comma, we'll write f of x approaches what? So when we're on the right side, which is here, we are ending up, which is positive infinity. And then we're going to say as x approaches negative infinity, which means when we are on the left side, where are we ending? It's end behavior. We're ending down. So we're going to say f of x approaches negative infinity. All right. Okay, I'm going to keep working my way around. Let's answer zeros. Our zeros are where we cross the x-axis. So I'm going to kind of go over this in green. I'm crossing the x-axis here, here, and here, where I've just highlighted as I said here. Now, what are those x values? Okay, we're going to say our zeros are at x is equal to, we were at negative 4 for x, negative 2, and 0. Okay, I crossed the x-axis 3 times, so I have 3 zeros. Okay, I'm actually going to answer domain first and then range. Domain, okay, we are moving outwards, left to right forever, so our domain is all real numbers. Our range, our lowest to our highest, because one end is ending down and the other side is ending up, we are going down forever, up forever. That's a range of all real numbers. And now I'm going to come back up here to turning points. And those are the x and y values of our highest and our lowest, like bumps. So I'm going to say I have a turning point right here where I just drew an arrow. That is a maximum. So I'm going to say I have a max at the value of that coordinate. And if you're using your Desmos app, I would click on that dot and it would tell you that that is negative 3.15, comma 3.08. Okay, that's a relative max. And then we have a min, and I'm going to draw a green arrow right now to this spot. That's a lowest turning point. So I have a min, and if I click on that dot, it's going to tell me the value for x and y is negative 0.85, comma negative 3.08. Okay, now my increasing and decreasing intervals. So we're going to cut basically the x-axis into sections based on where my turning points are. So right here was a turning point, and right here. And I'm going to write down the x values for those points. This x value was negative 3.15. This x value was negative 0.85. Now notice I have 3 sections, and the label says 1, then 2, then 3. Now we go left to right. Okay, so between negative infinity and negative 3.15, between those x values, are we going up or down from left to right? You'll see we're going up. So that's an increasing interval, and we're increasing between negative infinity to negative 3.15, those x values. Now my section 2 that I labeled, that's between x values negative 3.15 and negative 0.85. Between those two x values, from left to right, we're going down. That's a decreasing interval. So we say we're decreasing from negative 3.15, comma, negative 0.85. And then in my last section, okay, from negative 0.85 to positive infinity, we only use x values, so from left to right, we're back to going up again, increasing. So we're going to say from negative 0.85, comma, infinity, we are increasing. All right, don't lose this paper. Hopefully it will help you have some reminders when we take our test. And good luck on your assignment.